Okay, so we're going to go ahead and get started here. If at any point anybody has any questions, please feel free to put them in the Q&A box, and Jim and I will do our best to answer them. So we'll go ahead and get started here. My name is Scott Carlson with MTH Pumps. I've been here for almost 26 years now. My co-host today is Jim Shackman. He is our Mid-Central Regional Sales Manager. And so we'll go ahead and get started here. Just to, for those of you just getting in, I did put up a little poll to try and gauge where we're at with the people attending today, and I got a couple of them that we'll do throughout the presentation here. So go ahead and get started. So just a little bit of information about us. MTH has been in business since 1965. We are a family-owned operation here. We're on our second generation. Dave Tremaine was our founder. He is 93 years old and he still comes in every day. But his son, Tim Tremaine, is the president. We currently have around 85 employees, but we're pretty consistently growing. All of our products that we manufacture here in the United States. There are a few parts that we can't control, motors and stuff like that, but for the most part, everything we do or everything we sell, we make here in the U.S. In our facility. We are ISO 9001 compliant, as well as 14001. We have been ISO since 2012. Our entire facility has CNC machining throughout because we do make everything here. And we are vertically integrated to the point that we even have our own foundry and our own pattern shop. Some images of our facility. You can see we have a full sales office. When you do call into MTH, you hit 2 for the sales office and you do get a human being. We don't have any kind of automated system. So when you call, you'll get a live human. We have full testing facilities, R&D, as well as all the machinery. Some more pics of our location. We do have a warehouse that has millions of dollars of parts in inventory at all times. Every single pump that we make, we build as ordered because there's so many combinations between the seals and materials and motors that we couldn't possibly build them and have them sitting on the shelf. So when we do build them as ordered, we also test them. So every single pump that leaves here is 100% tested before it leaves.
Scott,
yeah.
If I may interject here for a second, interrupt, I apologize. There has already been a question about whether these slides would be available afterwards, but I believe I stand, unless you want to correct me, that this whole presentation will be available. Is that correct?
Yep. As soon as this is over, you'll get an email automatically from our webinar software that will make a download of the presentation as soon as it's over. So we'll have that available. So anyway, certifications. We, like I said, ISO 9001, as well as the ISO 14001 that we achieved in 2022. We are part of the Illinois Manufacturers Association, and one of our local associations, the VIA, we're very heavily involved with, to the point that just this year they have their award ceremony. That's basically the Grammys of the industrial world in the Midwest, and we took home 4 of these awards, so we're pretty proud of that. So some of our capabilities, we have several engineers on staff that are always active. We have solid modeling designs. We have rapid prototyping, several other, several other abilities, but some of the most important ones we have here is that we do own our own foundry right next door. And a couple of years ago, we outfitted it to be able to do investment cast stainless steel, as well as the bronze and iron and aluminum that we were already able to do. So we'll get into some of these applications here real quick. The first thing to know about regenerative turbine pumps is that their main characteristic is that they have a steep head capacity, they're higher pressure than they are flow, which is the opposite of a centrifugal pump, that are known for their flow and not necessarily their high pressure. An example for context is that this is a multi-stage regen turbine. You can see the extreme amounts of pressure that it can achieve, but if you'll also notice, the horsepower for it is higher at higher pressures. When you compare that to a centrifugal pump, the centrifugal pump goes at a higher horsepower as the flow increases. So it's exactly the opposite as a centrifugal pump. Some of the other pump characteristics, besides the high pressure, are that they have a compact design. They're usually only a couple of parts. Motor bracket, impeller, and casing, as well as the motor and seals and hardware. So there's not a lot of difficulty in working on them. They are a pulsation-free flow. If you compare that to a diaphragm pump or a piston pump that you would use for high pressure, those both have pulsation to them. Part of the reason for that is it is a free-floating, balanced impeller, so we don't fasten the impeller to the shaft. It works itself through the whole time. I'm gonna go ahead and throw up a little poll here just to see what characteristics are most important to you. Another characteristic here is the NPSH characteristics, because all of the work of the fluid is being done on the outside of the impeller. Any vapor that does form in it can exit out of the pump immediately and doesn't have time to accumulate like it would in the eye of a centrifugal impeller. So there is little to no cavitation with regenerative turbine pumps. And we do have several different materials, which we can go over later. So just to give you a brief how they work, when you think about the most common pump on the planet, it's usually a centrifugal pump. The way it works is the fluid goes in the center and then gets flung outward by the impeller vanes. So the fluid only gets touched one time by an impeller vane before it hits the volute and exits out of the pump. If you want higher pressure with this type of pump, you need to add multiple stages in front of it. And sometimes you can get up to 25 stages or even higher in some instances to achieve the same pressure that we can do with just a single impeller. And part of the reason that works is because our impellers, first off, work the fluid on both sides at the same time. So the water goes into the inlet side and it is split in two. And as well as being split in two, when the centrifugal pump has to go from impeller to impeller, and each impeller builds up a little bit of pressure, a regenerative turbine pump goes from vane to vane and builds up a little bit of pressure in each vane. So by the time it gets to what we call the water stop, it exits out at a much higher pressure than when it started. But it's usually quite a bit lower flow than what a centrifugal pump would have. So to compare that with a multi-stage centrifugal pump, in this example, we have 3-stage up to 25-stage, and then we have the MTH models. These are all single impeller models. So they're all one impeller and they can hit multiple spots with different models. Here we've got, as our example here, a 19-stage pump that we can hit any part of this curve in its preferred operating range with just a single impeller of one of our T51s. So for comparison, you would have this large vertically stacked pump for the multi-stage centrifugal versus just our single impellered pump and motor with our T51. Another advantage is the over a rotary vane is that a rotary vane will have sliding parts and parts that rub constantly, as well as pulsation. With a regen turbine, because the impeller is balanced and no parts make contact, you'll have much longer life. You do get the pulsation-free movement, and there's several different capacities and pressures available. And we can do several different mountings. If you run into a situation where you have extremely hot water, you can always add a Francis vane style impeller to the front of our multi-stage regen turbines, and what that does is it can knock the NPSH, that's the net positive suction head, required down to as low as 2 feet on certain models, and some of them can even go down to just 1 foot. So when we look at our applications here, we have air, heating, and refrigeration applications. There's just a different diagram that shows the different places that you can find regenerative turbine pumps. We'll go over each of those here. The first one is in booster service. Anytime you need to move fluid up multiple stories or boost the pressure of fluid that goes from city pressure to a higher pressure, um, or whatever the source may be, regenerative turbine pumps are ideal for that because they can increase that pressure without necessarily increasing the flow. Um, so in skyscrapers, they use regen turbines to move water up multiple floors on car and truck washes. Um, Oftentimes, they can do the entire operation of shooting the water directly onto the vehicle, but in some instances, um, can act as a priming pump to increase the pressure before it hits the main pump. You would see that in like a water jet cutting tool. Um, we like to show this picture off. We sold some pumps to NASA. We sold multiple pumps to NASA where at the top of the rocket head in Florida where they launch, the temperature can get really, really warm while the rocket is sitting there. And so they use our pump to circulate Freon and other refrigerants from all the way from the base all the way up to the top of the rocket until the time of launch. And then at the time of launch, the hoses just break away the as the pump or as the rocket takes off. Um, so one of the first applications that regenerative turbine pumps were made for is boiler feed. That is where it all started. Because there are so many boiler systems and boiler feed systems that have come and gone through the years, different companies have manufactured them. There's oftentimes, if you get into an older building where there's a boiler feed system, you'll look at the boiler feed pump and it's pretty much unrecognizable. So we've come up with this chart that's our boiler feed selection chart, that if you can find out what the boiler horsepower is and then find out what the PSI inside the system is that it needs to overcome. We have pre-selected several pumps all the way up to 700 horsepower boilers and 250 PSI. And there's some other ones that we can do besides that. We would just have to custom size them up for you, but this is available right on our website. Next, accompanying the boiler feed would be the condensate return. After the water has been traveling around in the piping, heating up whatever process is it's being used for in heating, the steam condenses back into water and empties into a condensate return tank. With the condensate return tank, you can either put the water back into the boiler feed system, or you can go directly into the boiler with it. If you go into the boiler feed system, usually a centrifugal pump is acceptable. We do make a small line of centrifugals, a 4, 5, and 6 inch version. And then for the condensates returns, if you want to go directly into the boiler, we have all of our regenerative turbine pumps have this flange that we can replace the casing of. And if you'll notice, this flange is blank. It's because we keep all of these flanges in stock as blanks, and we have one of our CNC machines pre-programmed to cut the holes needed for the pump so that it fits directly onto the existing tank. We have those for Sterling, Shipco, Aurora, Wiseman, Dunham Bush, several of them. There are a lot of different brands out there, and a lot of times it just takes the shape of the the fitting to go directly on them without having to do modification. We also have strainers. So in boiler feed, if you have a lot of debris in the water, scale, whatever, we do have strainers available. Next on our list here is fire suppression systems. In larger buildings, especially in more city type situations and urban situations, you have what's called a maintenance pump or a jockey feed pump. And what that is that you have your main pump. If there's ever a fire, the sprinklers are activated, the main pump kicks on, dumps hundreds or thousands of gallons a minute onto the fire through the sprinkler systems to be able to put out the fire. Well, while the system remains dormant, you'll have leaks in the system, whether it's a drip on some floor somewhere or it's a check valve that's pushing water back into the source tank. Whatever the case may be, you need to have a small higher pressure pump to recharge the piping where the sprinklers are. And regenerative turbine pumps are really good at that. They just turn on once every couple hours for 10 minutes. The system's recharged, and it's good for however long it takes for that pressure to go back down again. So just like our boiler feed system, our boiler feed charts, we do have a jockey pump selection chart where if you know the pressure that is in the lines that are holding the sprinklers, keeping them from going off, as well as the main pump GPM, we have a pump that matches it. I don't know if you can tell from looking at this, but if you need to keep our pumps on the shelf for situations where you would need to have one available right away, you can see that basically with one or two or three pumps, you can cover pretty much a whole huge area of pressures and flows to be able to have your pumps readily available. Next on our list here is cooling systems. Any kind of circulation for fluids, whether it be geothermal heating and cooling or any kind of equipment cooling, regenerative turbines are ideal for that. With the geothermal heating and cooling, when you have piping that goes down thousands of feet and then back up, there's a lot of twists and turns in the piping and a lot of elbows that cause a lot of friction losses. So to maintain that flow, you need a high pressure pump to overcome all those friction losses. So regen turbines are ideal for that. You also have situations where you have a piece of equipment that the fluid needs to go right across the head of the cutting tool, especially with plasma and lasers. As they heat up, the width of the cut becomes inconsistent, and it's hard to make parts with intolerance when the temperature isn't controlled. So you can use a regenerative turbine pump to push fluid directly across the cutting tool. That gives it the ability to stay cool and consistent the entire time it's in operation. Next, we have chiller applications. Because our pumps are compact, a lot of chiller manufacturers like to use them because they fit inside of their chiller, which is this small unit. It actually can control the temperature of specific pieces of equipment down to even 1/4 of a degree. When you have something like an MRI machine that you're trying to take a picture of somebody's brain, you want to have the lens be at its maximum focus and be able to um, take a consistent, clean picture. And so you need to have that temperature regulated so that there's no twisting or bending of any kind of the materials that are taking the picture.
Hey, Scott, if I can interject for just a second, there's another question, and it's in reference to our Jockey pumps.
Okay.
And someone is asking if they are NFPA rated.
They are not NFPA rated because it's a Jockey pump, not the main fire pump. It's a part of the hardware, so it doesn't need to be NFPA rated. Or so we've been told. We've never run into a situation where we couldn't sell a Jockey pump because of that. Most of those ratings are for the main pump. This is part of the maintenance package for that main system. So it does not need to be NFPA rated as far as we know. So hopefully that answers your question.
Thanks, Scott.
Yep. Moving on here. Other temperature control. When you have plastic molding machines that need precise temperatures and rapid cooling, regen turbines with their high pressure are ideal for being able to do that. In high volume printing presses, you could find a regen turbine that would circulate coolant throughout the system to make sure that the ink is laid down on the paper correctly at the right temperature. If it gets too warm, it gets runny. If it's too cold, it doesn't stick to the paper, so on and so forth. Other applications are cooling of lasers and any kind of machine tool oil, any operation where temperature is critical. A lot of times you'll find a regen turbine supplying the high pressure fluid that's doing the cooling. Other high pressure systems are any kind of closed loop system. That is where the system with the fluid in it is completely closed off from the outside world and circulating inside of a piece of equipment, usually under pressure. All regen turbine pumps work on the principle of differential pressure. So if you have a system that has 60 psi on one side and you need 100 psi in the system, you would size the pump for 40 psi because that would make up the difference between the 60 already there to get you up to that 100. So several different chemical processes. Our materials go up to 3/16 stainless steel. So anything that can come within that is any fluid that is okay with that is we can do. So any kind of refineries, textile mills, wood mills use our pumps quite often for that. Any kind of fluid handling, fluid transfer. One of the things that I like to show folks is that this piece of equipment right here is called a quench gland. We designed it to go along with our T41s and T51s. What it does is it puts an oil barrier between the mechanical seal and the outside atmosphere. The reason for this is because the fluid that they are pumping will crystallize if it's exposed to the atmosphere. And the way the mechanical seal works is you've got your seal seat and rotating element, and they have a barrier of fluid between them that is so tight that it makes the seal and keeps the pump from leaking. Under most circumstances, it evaporates as it hits the atmosphere. Well, with this particular application used in the pulp and paper industry, it it would start to form crystals on top of the surfaces of the seal and will make the seals wear out prematurely. So by using this quench gland, it has a sight glass in it, and we fill it with oil before we ship it. And what the maintenance plan can do is, as the process is going, the maintenance person can walk by and shine a flashlight in there, or just look and see in there. And if the oil level is higher or lower or cloudy, then they know that the seal is leaking and it's time to change the seal. Oftentimes, the oil won't hurt the process as much as having a catastrophic failure of the pump, causing the whole entire system to bind up. So we have customers that are really happy that have that situation, that we have this available. And then the DAF we'll talk about in a second. I have a whole slide on that. One of the other services is de-icing service. The de-icing fluid is a really, really nasty fluid. My wife was in the Air Force, and she used to tell me about this stuff. I guess it's really slimy, and it keeps ice from forming on the wings so that the airplanes can take off. And it's particularly hard to pump. And our pumps do a fine job of that, because they can maintain that high pressure the whole time to make sure it gets through the hosing before it hits the airplane wings. Deionized water handling with our regenerative turbine pumps. We have a sealless can version of it that get used quite a bit for anything that has deionized water that needs to be extremely clean. So Washdown of circuit boards, other electrical components, any kind of reverse osmosis system can use our pumps. Here's our sealed, our sealless can motor pump. The way it works is the fluid goes in to the inlet side, and then it's drawn across the bearings, and then there's a thin layer of stainless steel lining between the rotor and the stator, and then it goes back through here through the back bearing, and then the center of the shaft is hollowed out all the way through, so the fluid can continue on back to the front, and then go through one more bearing before it exits out the discharge side of the pump. So it keeps about a half a gallon a minute flowing smoothly through the pump. So it's extremely quiet while it's operating, and there's no chance of any leakage because there's no mechanical seals that can fail. Another application here is high pressure coolant. Anytime you have a high pressure cooling machine hooked up to your CNC, they found that by using extremely high pressure, sometimes between 300 even to 1,000 psi, when they're introducing coolant at that high of a temperature directly on top of the cutting tool, what they found is that it makes the cut that the cutting tool is doing act like it's the first cut for extended amount of time. They can make parts faster and more accurately with tighter tolerances by using this high pressure coolant for the machines. And so that's one of the applications. One of our newer applications we started getting into is we have our HP series. This is our very first welded, hermetically sealed pump. It's the entire pump is built inside, and then it's welded shut so that there is absolutely 0% chance of leakage. It's designed for running freons, refrigerants, and CO2. It can handle a case working pressure of, I think, 800 psi. More. They use them for economizer packages as well as two-phase cooling and direct-to-chip cooling in data centers and computer processes. The way the economizer packages work is when you have a refrigeration system that's cooling something, it's using a large compressor. That compressor can be anywhere between 10 horsepower up to 30 horsepower, and it has to run 24 hours a day, 7 days a week in order to keep the system cool. And with this economizer package, it can be installed in such a way that it is put on the roof with a heat exchanger on the roof of the building. And on days when it's cool outside or at nighttime when it's cooler, as long as the temperature is lower than what they're trying to cool on the inside, they can turn off this compressor and bypass it and use the outside air for doing that. When you have a critical temperature sensitive product like food or a data center, they oftentimes have these in repetition. So you could have 100 or more compressors running at one time. And if they can shut off this 15 to 20 horsepower compressor and turn on our little 1 to 3 horsepower motor instead, some buildings can save up to $1 million a year in electric bill and have a huge carbon footprint savings. Getting into a little bit of the water and wastewater side of applications here, there are several areas that a regenerative turbine pump can be found out in the field. First one, and one of our bigger uses right now, is for DAF, dissolved air flotation. So what happens if you're unfamiliar with DAF, when you have extremely dirty water, whether it's from food processing or any other kind of waste management, as it goes through the system, it hits the final step where it still has minimal particles, very small particles in the fluid that need to be cleaned out, and you can actually introduce air directly into the suction side of the pump, and the air will pull itself in on a vacuum and will mix inside of the impeller and water channel, and it'll shear the bubbles to make these micro bubbles, which kind of looks like smoke in clear water, and they grab onto the particles and pull them up to the surface where they can be skimmed off so that you can either dispose of the water properly or reuse it in a different process inside of whatever facility is using it. When it comes to food processing, a lot of times they filter the water out as much as they can, but they can't put it down the regular drain because of EPA laws and the extreme hardship it would give the wastewater treatment plant. So they use this DAF system. Typically, they used to just store it, and when after they get a tanker full of it, they send a truck to come get it and take it to a rendering plant for further rendering. Using a DAF system, they can do it all right there and be able to clean the fluid enough to be able to go right down the drain. One of the other processes that they use a DAF system for is in the shale and fracking industry. They use an extremely high pressure pump to pump water down into the surface to push all that oil up. and when they finish getting all the oil out of the ground that they can in that area, they have to pull that water back up out of the ground. And when they do that, that water is pretty much toxic waste. Up until a few years ago, when they figured out they could use this system, they used to just have to store it for an indefinite amount of time. But now, by having a DAF system on site, they can run it through there, and a lot of times they can pull up the remaining particles that are in the water enough to not necessarily put it down the drain or dispose of it, but they can reuse it at a different site, so they can move it from location to location. When you use a regenerative turbine pump for the purposes of DAF, the typical system for a DAF would have a large centrifugal pump and an air compressor, and it would be moving a lot of water and injecting the air using a compressor, and then it would have to go through a mixer. It would have to get repressurized in a tank, and then it would have to go through a couple other processes and then go through. All of this equipment requires maintenance, and all of it is pretty expensive to be able to start up. So by using a regenerative turbine pump, the only things required are a vacuum gauge, a couple of and a line into the inlet, as well as a couple of valves on the ends to get it set up. So once it's set up, you have to put a little suction pressure on it, a little bit of discharge pressure on it, and kind of fine tune those three factors. Once you get that solution using a regen turbine, it's pretty much a set it and forget it type situation. So you can replace all this equipment with just a single pump. Some of the other applications here, we have seal flushing and extractors. With the seal flushing, if you have an extremely large pump that is operating on a regular basis, and it's got a seal chamber inside of it that contains a very large seal that is very expensive to replace, you can run a line of fresh water using a regenerative turbine pump to overcome the amount of pressure that is being produced inside of the larger pump, just to go through the seal chamber to help keep the seal cool and keep contaminants from hitting it or hitting the seal and ruining the seal. So you get a longer life out of that seal, and everything stays clean and cool inside of it. With the extractors, anytime you have any kind of operating piece of equipment that needs that is very expensive to shut down, particularly when you're dealing with marine equipment that has very large engines, regenerative turbine pumps, because of their extremely high pressure, can oftentimes refill fluids, sometimes change fluids without ever having to stop the engine from running. Some of the other operations here are groundwater remediation and filter backflush. With both of these, you have running water. In this case, it's going through a filter, and the particles that it's picking up inside of the filter will start to clog the filter, and you can extend the life of it by using a regen turbine pump to push the fluid backwards, and it'll knock all of these particles out and stir them up so that you can continue using the filter and extend the life of the life of the filter.
Scott, can I interrupt for a second? We have another question.
Sure.
It has to refer to our DAF pumps.
Okay.
And the question basically stated, will our DAF pumps see any solids?
No, all our DAF pumps, we use 316 stainless steel in case there is a couple of solids here and there. But for the most part, this is going to be the last step before disposing of the fluid or reusing it. So it does need to go through the entire process that it would normally go through before it hits the DAF system. The DAF system is always the last step. So this will be the part where it's picking up the micro toxins inside of the that are still in the fluid after it's been filtered and netted and whatnot. So the water that's going to be in here might be a little murky, but for the most part is going to be just about clean enough to put down the regular drain without having any issues. And those micro bubbles are going to grab onto those particles and pull them up to the top, to the surface where it's going to go through a skimmer and be pulled apart from the fluid before it goes into its final disposal, whether it be reuse or drain into a waste management city municipal system.
That answers your question. Thanks, Scott.
Sure. So, not necessarily a regen turbine, but one of our other applications here is we do have a version of our centrifugal pump that is set up. It's called our DC-10. There's a couple other companies that make DC-10s. Burke's makes one, AMT makes one, a few other companies, but it basically uses a 12-volt motor and is predominantly in the portable restroom area industry. So you've got these portable restrooms, you've got this tank has a divider in it, and it'll have all the waste on one side, and then it'll have clean water on the other. When you get to a site with a portable restroom, you can clean everything out, and then you can hose it down before and then clean it for cleaning purposes. So we have that, but the beauty of this design is that this uses the same fitting as a T31, so we can have access to a 12-volt version of our regen turbines with our T31s, and then we can also we have an OEM that orders our centrifugal pumps on a bearing pedestal, and then they hook it up to a power takeoff unit so that they can operate it without any electricity through whatever piece of equipment they're operating. In this particular case, this customer has a service that they take a vehicle directly out to a field where a farmer is plowing his field or harvesting, and he'll refill the diesel in one tank and then use our pump to refill the diesel exhaust fluid. So there is that option as well. Next on our list of applications is our hydrostatic testing. With hydrostatic testing, any other manufacturer that makes any kind of a tank, piping, or any other piece of equipment that is going to be put under pressure, one of the easiest ways to test it while it's still in the manufacturing process is to hydrostatic test it using a regenerative turbine pump. With the regenerative turbine pump, you can use your pressure gauges to decide what pressure you're going to test it at. You can have your piece of equipment fill up with fluid, and then you can run the pump to increase the pressure until it hits whatever pressure you want to test it at, and then you can close everything off, and you can be able to do all your inspections to make sure that there are no leaks coming from anywhere because of bad welding or seals or anything else. So it's a good way to hydrostatic test any piece of equipment. Another application here is pressure injection. So anytime you have any kind of wood that is going to be used outside, they inject creosote into the wood. That's how it lasts for years compared to untreated wood that you would put inside your house that would never be exposed to the elements. And the way they do that is they put all of the lumber in a pressure vessel, and then they fill that pressure vessel with creosote using a regenerative turbine pump at extremely high pressure, and it pushes the creosote into the wood and pressure treats it. They have a very similar process for concrete. When they're pouring concrete, depending on the environmental conditions, they can control how much curing agent they put into the concrete with a high pressure pump as well. Any kind of spraying, regenerative turbine pumps can hit that 1,000 PSI mark, so you can do a lot of different kinds of cleaning with that. In the food industry, you can use it for cleaning various pieces of equipment. When you have pressure that's at 1,000 PSI, we've been told, we don't know how true it is, that you can actually blow the feathers right off of chickens without using any other kind of equipment, just high pressure fluid. So we have those available for that. For misting, when you're at a construction site, and there's a lot of dust, especially if it's like demolition or waste or any kind of waste management service that is going to have a lot of dust naturally occur. They have these fans that are manufactured that have water lines with nozzles on the end of them, and you would use a regenerative turbine pump to push fluid through those nozzles to make a fine mist that blows out over the air, mixes with the dust particles that are in the air, grabs them and pulls them down to the ground. So you can control dust using these misters. The other piece of equipment here is laboratory equipment. Anytime you have any piece of laboratory equipment that needs high pressure, you can find a regenerative turbine pump. Especially since we have them made for the non-pulsation and for the extremely clean liquids. They're ideal for laboratories and because they're compact. Another application here is sampling. Whenever you have a facility that is changing the properties of a fluid throughout the entire facility, you need to have a centralized location in order to analyze the fluid at different points. So you can use a regenerative turbine pump to circulate that fluid throughout the system. And just like the geothermal, when you have thousands of feet of piping with twists and turns and bends in every direction, you have a lot of friction loss, and regenerative turbine pumps don't really care about friction loss. They're going to overcome that pressure and produce a consistent amount of flow so that you can do whatever kind of testing you need to do with the fluid at the time. So with that, some of our optional materials. I do have a couple of polls here. So if you want to answer these, just to give us an idea of what your industry is. Some of our materials of construction are standard material for almost all of our pumps is bronze fitted. So that's going to be a bronze impeller with a cast iron cover and motor bracket. We have an all bronze version of that, an all iron version of that. And then we do have almost everything in 316 stainless steel as well.
Scott, may I interrupt for a second? Let me
Sure.
interrupt for a second. I apologize. There's a couple more questions. One of them is, I think this has been answered, but it says, will either PDH or certificate of attendance be offered for these record keeping?
Actually, that was one of my questions, or that was one of my polls that I was gonna throw up there. I'll go ahead and throw it up now. We're actually working towards being able to offer those. There's a few adjustments we need to make on our presentations here, but we just recently found out that we could offer that, and so I was looking for to get some input from everybody in attendance today to see how useful something like that would be. I did find out that there are a couple of states that won't let us do it without going through some certifications, but for the most part, just about every state, I think there's only about 3 states that we wouldn't be able to have a qualified PDH, but we would be able to in everywhere else. So we're working on that. That's something that's coming down the pipeline here.
Also, too, Scott, it
Sure.
says, what are the highest power motors available for your pumps?
So for the close coupled pumps, we can go up to a 10 horsepower. For the flex coupled pumps, we can go up to 60 horsepower. So, and on our website, go ahead.
I'm just saying that I want to just add to that. Maybe you were getting ready to, and I'm going to interrupt you. The 60 horsepower, and if we can't go higher than that because I believe it's because of the shaft. Is that correct, Scott?
Correct.
All right.
So with our close coupled pumps, the shafts can handle up to 50, or in the 50-60 configuration can handle up to 3 horsepower. For 5 through 15 horsepower, they can max out at 15 horsepower with the standard pedestal mount. And then all of our long coupled pumps can handle up to 60 horsepower as maximum horsepower. After that, it will affect the shaft structure, so it cannot handle, the shaft can't handle more horsepower without a different design. So
Okay, and there's one last one, Scott. This says FYI, some states, and this may be you, I don't think it is. No, it's not. Like Tennessee will accept simple certificate of attendance documentary. It's a technical topic. So I
yep,
guess you're looking into that too.
we're looking into that pretty heavily, where we may be able to offer it as soon as the next one of these that we do in just a couple of weeks. So, but like I said, there's some modifications we need to make to the presentations to make them qualified. All of them, you have to have a test. So I would have to make a test that you would download and send in to me, where you would have to get 4 out of the 5 questions correct. And then we would have to give you a certificate. So I'm working on that. It's coming down the pipeline.
Thanks, Scott.
So like I had mentioned earlier, when you call the factory, you get a live person. So the all sales office ring is just 2. When you dial the phone number, you just hit 2 and it goes to the sales office. But here are the individual extensions of everybody working at the factory that would be a key person to talk to. If you have a return or warranty issue, we have a returns department, accounting, quality, and then pretty much everybody here is in the sales office, including me. And we're all here basically from 8 to 5. A few of us come in at 7 in the morning, Central Time. So if you're in Eastern Time and you need to call first thing in the morning, there's usually somebody here. So with that, some of the current projects that we have coming out. First off, MTH is very heavily into environmental sustainability, and because of that, I think it's last year. Yeah, last year we had 600 and something solar panels installed on the roof of our building for the purposes of producing power for our equipment. Found out that even with 600 and something solar panels, it's still only 30% of the amount of power that we use. So one of the things that's coming down the pipeline in the next couple of years is that the president of our company bought a piece of land outside of town that's 168 acres, and we plan on being fully sustainable with that amount of land with a brand new factory that is coming. It's not here yet. It's going to be a couple of years, but it's coming. Some of the products that we're working on a mag drive version of all of our T-Series pumps. So we will have the option of being able to outfit a special bracket that would go on the motor bracket to be able to remove the mechanical seal in lieu of a mag drive. One of the other products that we have, we just came out with and we're finalizing, is we had an OEM come to us and request an all plastic pump for whatever they were pumping, and for cost reasons they really wanted an all plastic pump, and when high pressure and plastic don't really mix that well, so we had to do some complete redesigns of our current configurations in order to be able to handle it. But we finally figured out that we can now do T31s in plastic, but they're not open for everybody yet. We're just finishing up for one OEM, and hopefully we'll have those available for everybody within the next year or so. So with that, let's throw up one last poll here. And if you have any questions later, please feel free to contact me. I'll be happy to answer any of your questions. Jim is also available. And I want to thank everybody for taking some time out of your busy days. We will be having another one of these in a couple of weeks. And I forgot to mention, in the fall, we will be having another session of our MTH School of Pumps. This is open to distribution only at this time. And what that is we will actually have you fly out here for 2 days for some intense training with all of our engineers. And there's a lot of information that you can learn from this. Like I said, right now it's only open to distribution, but it's coming down, or we're working on something more open. So with that, thank you very much.
Thank you, everyone.
And I think we're all good here. So
Thanks,
thank
Scott.
you.